Okay, let's continue the Norris type reactions of chemical reactions. The resulting intermediates are stabilized by obstructing the hydrogen radical from alpha position of the radical, produces olefins and aldehydes. By obstructing hydrogen radical from the alpha position of acyl radical by alkyl radical, products are ketones and alkenes. By undergoing decarboxylation or decarbonylation, uh, and one more method is by producing carbene intermediates. So stabilization rate in Norris type 1 cleavages depends on the nature of the carbonyl compound. So here I'm taking acetone carbonyl compound and it's in a ground state. When it is irradiated with the light source, more particularly lambda max of the acetone, it goes into a singlet state. And this will crosses the intersystem crossing and forming a triplet one. So triplet undergoes alpha cleavage. This kind is called a Norris type 1 reaction. This leads to formation of acyl radical and the alkyl radical. So this acyl radical can obstruct the proton from the means hydrogen radical from the alpha position, gives rise to ketene as the byproduct. This ketene can react with the nucleophile. Nucleophile, if the nucleophile is water, it can react. It can react and gives the acetic acid. If the nucleophile is amine, amide will be the product. So overall, ketene will be the intermediate. Depends on the nucleophile, the products are obtained. And alkyl methyl radical can undergo dimerization, forming a dimer product. Other possibility, a acyl radical also can undergo decarboxylation, forming a methyl radical. The methyl radical can undergo dimerization, forming a dimer product. This again a mechanism of acetone when it is irradiated with the lambda max of the acetone, forming the products of uh, ethane, ketene, and acetic acids are the. I will go to the next slide. The next slide, I'm taking okay. So no, Norris type 1 products are disproportionate products, dimerized product, and decarboxylation products. That means you need to remember Norris type 1 products are disproportionate products, dimerized product, and a decarboxylated product. If some of the carbonyl compounds, more particularly the strained carbonyl compounds and the unsaturated carbonyl compounds, they undergo decarboxylation predominantly. So look here, this is one strained carbonyl compound. This is also another. This is also one more. Means five-membered and below ones are called strained carbonyl compound. They undergo decarboxylation predominantly. So that means you know that this is alpha carbon, this is alpha carbon. As per Norris type 1 cleavages, here cleavage, here cleavage. That means CO is a living group. Carbon monoxide is a living group. It will go and forming a radical at 1,4 radical. 1,4 carbon radical is forming. Here there is a two possibility. One is cyclization. Another one is cleavage of this carbon and forming a ethene, two molecule of ethene. So this is again a strained molecule. Then formation of two molecule of ethene will be more favorable. So here I'm taking alpha beta unsaturated carbonyl compound. This when it is irradiated it gives you the alpha cleavage. Alpha cleavage means Nash type 1 cleavage, and CO is the leaving group. So forming a 1, 4 biradical. And here cyclization is not happening because of the strain. That's the reason pi electron or pi bond undergo homolytic cleavage, forming a pi bond here, pi bond here. So I'm taking one more example, a bicyclic ketone. Alpha cleavage occurs when it is irradiated, forming a biradical. And you know that this undergo homolytic cleavage, sigma bond undergo homolytic cleavage to get a relief from the strain. So then here one radical, here one radical. That means here double bond is formed. So that means 1, 4 diene will be the product. This 1, 4 diene can be isomerized to 1, 3 diene. So why you know that this is an isolated double bond one, there is no conjugation, but here there is a conjugation. That's the reason this kind of molecules are stable compared to this one. Let me go to the next slide. In the next slide, I'm taking few more examples. A dicarbonyl I'm taking. So this dicarbonyl compound, you know that alpha cleavage. Alpha cleavage means Nash type 1 reactions. Here cleavage, here cleavage. Then what will happen? You will get one radical here, one radical here. That's what the key intermediate. So then what will happen? Bond formation. That means a 3-membered strained ketone is there. And this is again undergoes cleavage. So alpha cleavage. That means again it is subjected to Nash type 1 reaction. That means here cleavage, here cleavage. That means one radical here, one radical is forming. And the obtained one is the trans alkene will be the product. So here I am taking a diketone, a strained diketone. When it is irradiated with the carbonyl lambda max, it is observed that alpha cleavage means Nash type 1 reactions. The obtained one is, that means here cleavage. Okay. Similarly, here cleavage, forming a isopropyl radical, and this isopropyl radical on dimerization forming a double bond, more particularly substituted ethene. So the mechanism, initially there will be a loss of carbon monoxide and then a 3-membered ring. 4-membered diketone is converted into 3-membered ketone. And this is again Nash type 1 reactions. Cleavage here. Carbon monoxide is the leaving group, forming a diradical. This diradical can form a pi bond, forming a compound. Okay, I will go to the next slide. In the next slide, I am taking few more samples. All these examples are belongs to the Nash type 1 reactions. So cleavage here. That means a biradical is obtained, and the biradical one form a sigma bond, and obtained one will be the a bicyclic, a tricyclic compound. Again, a strained 5-membered bicyclic ketone on irradiation with the carbonyl lambda max, it forms a hydrocarbon. This is also a bicyclic compound. Cyclobutanone hexanone will be the hexane, cyclohexane will be the product. So a ketone, symmetrical ketone on Nash type 1 reactions, cleavage, alpha cleavage here, forming a 2 tertiary butyl radical, and this can pick up the hydrogen radical from the another substrate, forming a tertiary butane, and then isobutane are the product. I will go to the next slide. In the next slide, I am taking a symmetrical ketone, more particularly dibenzyl ketone, and this is again, this is also a ketone. Again, this is also a symmetrical ketone, more particularly biphenyl methyl ketone. In both the case, there is a alpha cleavage here, alpha cleavage here. So then The obtained one undergoes dimerization. This radical undergo dimerization. In this one, benzyl radical undergo dimerization, forming a hydrocarbon. So here, in addition to these two, one more product also obtained. So that means if one of the obtained biphenyl methyl radical, if phenyl group is going, then that will react with the biphenyl methyl radical, forming this product. Here I am taking one more example. The example is cyclopentanone derivative. This on irradiation with the lambda max, alpha cleavage here, So forming a obtained biradical, obtained 1,4 biradical undergo sigma bond formation, forming a cyclobutanone moiety. This is the cyclobutanone moiety. From here to here, there is a loss of carbon monoxide. Then both the sigma bonds here and here, if it undergo cumulative cleavage and forms a double bond here, that is nothing but a 2 equivalent of biphenyl ethane are the product. I will go to the next slide. In the next slide, I am taking few more examples. So look here, this is again a cyclohexanone derivative. If this is on irradiation, alpha cleavage, the alpha cleavage means to the carbonyl alpha cleavage. Here cleavage. That means one radical on this carbon, another radical on this carbon. So giving rise to a 5-membered hydrocarbon product. So in addition to this, one more product also formed. For that explanation, I am taking here. So when this is, instead of going to alpha carbon cleavage, if there is a 1 alpha carbon cleavage, in such case, one radical on the acyl radical, another on the alkyl radical. In this one, alpha carbon hydrogen obstruction, that means this hydrogen going over here, that means aldehyde is obtained. And once the hydrogen radical is removed, here there is a radical formation. This radical and this radical forming a double bond. This is again one more. Let's take one more example. So again, it's a simple one. What is the simple? Cyclohexanone. So cyclohexanone on irradiation, more particularly lambda max of the cyclohexanone, forming cyclobutane and propene and ethane. These are the products. How these products are obtained? For that mechanism, let's look into that. Alpha cleavage means this is an alpha carbon, this also a alpha carbon, both the alpha cleavage forming a 1,5 diradical. This 1,5 diradical on sigma bond formation, cyclopentanone will be the product. Suppose obtained 1,5 radical, if it obstruct the hydrogen radical from the alpha position, then there is a conversion of this CH2 into CH3. This leads to formation of radical, secondary radical. Then what will happen if there is a cleavage on this carbon-carbon bond formation? Here there will be a double bond formation. And here there will be a double bond formation. This is how a propane and ethene is formed. Let's take the one more example. Again, same example only I am taking. Previous example is also a cyclopentanone. So this is also a cyclopentanone, but products are different. So here, cyclopentanone, propene, and ethene are the product. But when it comes to here, a ring contraction. Ring contraction means conversion of cyclohexanone to cyclopentanone and the two different products. Let's look into the mechanism. If it is a alpha cleavage, means only one carbon is cleaved under Norris type 1 reaction, it is possible to get alkyl radical and the acyl radical, and then alpha hydrogen, okay, obstruction. Then this hydrogen is forming a bond here. So that means CH2 radical is converted into CH3. Then here there is a secondary carbon radical is forming. This radical and this carbonyl radical, acyl radical, if it forms a bond, then the obtained one is cyclopentano. Methyl cyclopentano will be the product. Suppose after alpha cleavage, 1,4 radical is obtained. If there is a cleavage, means obstruction of hydrogen radical from the alpha carbon of the acyl one, then what will happen? Here, here one radical, and the CH3. This is the CH3. This radical and this radical forming a bond, and that is how a ketene is obtained. This is about the symmetrical ketones. If we are taking an unsymmetrical ketone, see, look here, this is one example for unsymmetrical ketone. Cyclohexanone is a symmetrical ketone. Cyclohexanone is a symmetrical ketone. 2-methyl cyclohexanone is the unsymmetrical ketone. In such cases, this also undergoes Norris type 1 cleavages, photocleavages, forming a 2 product. Out of 2 product, one the product will be 95% product is formed. That means predominant form is formed. Cis product will be the less yield obtained one. So let's go to the another slide. In the slide also, I'm taking unsymmetrical ketone. This is again unsymmetrical ketone. So what it means, electron-rich carbon is the where there is a cleavage. If there is a cleavage here, you can observe that a secondary carbon and the acyl radical are the intermediates. And then alpha hydrogen radical cleavage forming a ketone are the product. So here I am taking, this is again a symmetrical ketone. This is not the unsymmetrical ketone. This is only the unsymmetrical ketone. So in the symmetrical ketone, alpha cleavage, forming a dimethyl benzene radical. This dimethyl benzene radical undergo dimerization, forming a cycloocta, dibenzocyclooctane are the products. I will take one more example. And of course, this is also a symmetrical ketone. This symmetrical ketone on irradiation with the lambda max, it is observed that cyclobutano-benzene are the product. And here, trans product is the major product. That's because of the stability. Okay. Why the stability? Formed radical is stabilized. And both the case, the formed radical is the benzyl radical, and this radical is stabilized through resonance. I will go to the next slide. The next slide, I'm taking a few more examples. So here, again, this is also a symmetrical ketone. This on Norris type 1 reactions, cleavage here. Then what will happen? You know that here dimethyl groups is there. So one of the methyl hydrogen obstruction forming isopropyl group, and since there is a loss of hydrogen radical, formation of radical on this radical combine and form a alkene. Similarly, this is again one more example of the unsymmetrical ketone. This is again unsymmetrical ketone. Then in such case, more substituted carbon will be cleaved. Then what will happen? This carbon is cleaved, forming a radical, alkyl radical and acyl radical. And then what will happen? Alpha hydrogen of the alkane radical obstructed. That means this hydrogen is moving over here. Then formation of radical here, forming a pi bond, forming the product in 97% yield. So I will take one more example. So here, cyclobutane I am taking. This is again a quite interesting example. Why quite interesting example? Because here 2 kinds of reactions are formed. two products are formed. One product is because of the Norris type 1 cleavage. Another product is because of the Petrino-Bucci reaction. So you can, if we are looking at the mechanism, the first step is the alpha cleavage. So forming a 1,4 acyl radical and alkyl radical. This acyl radical and alkyl radical react with the butadiene. Okay, 1,4, 1,3 butadiene. So forming a cyclic compound. Another possibility, this product is formed because of the Petrino-Bucci reaction. What is Petrino-Bucci reaction? Reaction of carbonyl carbon with the alkene is called Petrino-Bucci, and here oxetane are the products. So I am taking again one more unsymmetrical ketone. In case of unsymmetrical ketone, more substituted carbon-carbon will be cleaved. So after cleaving, it leads to the acyl radical and the alkyl radical. And here one double bond is there. This double bond moves over here. If the double bond is moves over here, then there will be a moves means alpha homolytic cleavage. The double bond undergoes homolytic cleavage, forming a pi bond here, leaving radical on this card. Then what will happen? This radical undergoes cyclization, forming a 5-membered cyclic ketone with the vinyl group as a substituent. This is how the 7-membered ketone is converted into 5-membered ketone with the vinyl as the substituent. I will take one more example. So again, cyclobutanol. This on irradiation. Suppose this is again this irradiation in presence of the solvent. That means solvent also react with the react in the intermediate stage. So that is how ether moiety, cyclic ether and unsymmetrical ether is also obtained. So Norris type 1 cleavage means alpha cleavage forming a alpha radical, alkyl radical and acyl radical. Suppose at this stage, if there is a homolytic cleavage of the carbon oxygen bond, then what will happen? There is a formation of carbene on the alpha carbon, and there is a radical formation on the oxygen. That oxygen and the oxygen radical and the alkyl carbon radical forms a 5-membered ether one with the carbene radical formation. This carbene radical react with the alcohol, more particularly methanol, forming a ether product. So in the next slide also, we'll take one more example. So again, this is an unsymmetrical ketone. So unsymmetrical ketone means more substituted carbon-carbon bond will be cleaved. So then the obtained one is alkyl radical and acyl radical. And then obstruction of the alpha hydrogen of the alkyl radical. Then hydrogen will come over here. So forming a aldehyde and double bond is formed between these two carbons. That means a cyclopentenyl aldehyde will be the product. This is the one. So let's take one more example. This is also again unsymmetrical. What is the difference between these two? So here in this irradiation, there is no solvent is there, but here there is a solvent. So solvent gives a different product, more particularly ether moieties. So this reaction, if we are carried out in presence of the alcohol, then as usual, the first step will be the alpha cleavage, more particularly more substituted carbon cleavage, leaving behind alkyl radical and the acyl carbon radical, and there will be a carbene formation. Carbene, how the carbene is formed? Because of the homolytic cleavage of the carbon-oxygen bond. Here, two radical is formed, and the radical formed on the oxygen react with the radical of the alkyl radical. And this you don't consider. This hydrogen radical loss you don't consider. So that is how the carbene is formed. This carbene react with the alcohol, so forming a ether product. I will take one more example. Okay. So here here we are giving an examples of beta cleavage. So 2, 3 examples we are getting. This is alpha carbon, this is beta carbon. So beta cleavage we are considering. So beta cleavage means this bond is break. So forming a radical here, then radical here. So then what will happen? Obstruction of this radical. So forming a 2 radical on these 2 carbon and forming a cyclo means beta cleavage leads to the formation of alpha beta unsaturated carbonyl compound. This is one conversion of ketone, cyclic ketone to alpha beta unsaturated carbonyl compound by the beta cleavage. So here also you can consider that epoxides. This is called epoxide. Suppose a molecule contains epoxide as well as the carbonyl compound. In such case, the beta carbon means carbon oxygen cleavage. So forming a radical on the alpha carbon, then alpha carbon hydrogen obstruction. So forming a 2 radical on the carbon and oxygen. So forming a one more uh, ketone. What it means? It means that epoxy carbonyl compounds are converted into 1,3 dicarbonyl compounds. 1,3 dicarbonyl compounds are nothing but a active methylene compounds. What it means? It means that epoxy carbonyl compounds are converted into active methylene compounds by the beta obstruction. Let's take one more example. So here, this is again unsymmetrical ketone, but again, what is the difference? It's an alpha beta unsaturated carbonyl compound. If there is a cleavage here, then there will be a formation of alkyl radical and acyl radical. In such case, since there is a pi bond is there, this pi bond undergo homolytic cleavage. And then what will happen? Here one radical, here one radical. That means here double bond formation and also a 3-membered cyclic moiety formation. So this is a 3-membered cyclic moiety and the ketene is formed. This since this reaction is carried out in presence of a solvent called methanol, methanol react with this carbon forming a nester. So you know that here one more product is formed. To explain this product formation, we are taking a cleavage, alpha cleavage, forming a compound here. So what is the difference between this? In this intermediate, pi electrons are involved in homolytic cleavage. In this one, alpha hydrogen obstruction from the alkyl radical side. So forming a product. How the product? RDA is the product. And more particularly, it's a alpha beta unsaturated RDA. So I will take one more example. So again, this is also a unsymmetrical ketone. Again, you know that here pi bond is there. So pi bond cleavage is not the alpha cleavage. So here is the cleavage. If there is a cleavage here, again acyl radical and alkyl radical are the key intermediate. Then what will happen? You know that the carbon oxygen pi bond cleavage that leads to a carbene radical, and there will be a new bond formation between the oxygen radical and the alkyl radical. So that is how a ether, cyclic ether with the carbene is formed. Cyclic ether with the carbene will react with the alcohol, so forming a ether. So this you can take it as a alcohol. So I'm taking one more example. This is again a unsymmetrical ketone, and more substituted carbon, alpha carbon will be cleaved. So forming a carbon radical and acyl radical. Okay. Then carbon radical and acyl radical. And then you know that a three-membered strained moiety, that's the reason here homolytic bond cleavage. That means here one double bond is forming, and then cyclization from this carbon radical to this radical. So cyclization. So forming a compound called vinyl cyclobutane. So similarly, again, a unsymmetrical ketone I'm taking. So here this carbon will be the more substituted carbon, and here there will be a cleavage and forming a radical, alkyl radical, acyl radical, and this carbon homolytic cleavage, and then cyclization forming a three-membered ring ketone with the vinyl as the substituent. I will go to the next slide. In the next slide, I'm taking two more examples. Look here, this is a continuation explanation for the different product formation. Here one radical, here one radical. Suppose instead of breaking this bond, if this bond undergoes homolytic cleavage, then what will happen? Here one radical, here one radical, here one radical, and then here radical, here radical. So it can be converted into this bond formation, okay? And then this can be, this is again naturally occurring carbone. Name of this compound is carbone, okay? So that means the rear, what you call Nash type 1 reaction method of carbon synthesis. So this is nothing but this one means both are identical structures. Then cleavage here. Why it is cleavage here? A three-membered will be the strained one. That's the reason it's cleavage. So forming a two radical. Here one radical, here one radical. And then what will happen? Okay. Then a radical here, and then radical here. And this is again radical. And this can undergo cyclization forming cyclobutano propynyl. Okay, allyl cyclobutanol is the product. I will go to the next slide. In the next slide, I'm taking one more example. Again, this is a symmetrical ketone. This one irradiation gives removal of carbon monoxide. Okay, hydrogen obstruction from this carbon forming this product. And then suppose if there is no hydrogen obstruction here, then cyclization, then this will be the product. That means you know that 1% product, 3% product. And then if there is this is again 25% product, this is again 11% product. And then from here, this one, how it is formed? Again, obstruction of this carbon only, this product is formed. Okay. So from this product, aldehyde. Aldehyde means again obstruction of this, that means only one CC bond, alpha carbon bond cleavage, then aldehyde will be the product. I will go to the next slide. In the next slide, I'm taking epimerization. So epimerization means, you know that conversion of cis to trans to cis is called epimerization. That means a diastereomer. So whatever I'm taking is the diastereomer. This is a diastereomer. Why diastereomer? Because this is one chiral carbon, this is another chiral carbon. And this on irradiation with the light of a lambda max of the carbonyl compound undergoes epimerization. That means this will convert as a away from the observer this substituent will come as a towards the observer. That's called epimerization. How this epimerization occurs? As usual, again, this is also an example for unsymmetrical ketone cleavage, more particularly carbon, more substituted carbon, carbonyl carbon cleavage. So forming a intermediate. And here there will be a conversion. What is that conversion? Pyramidal inversion. So this is again pyramidal inversion. Because of this pyramidal inversion, the stereochemistry is changes. What is the stereochemistry here? Cis-cis is the stereochemistry. Obtained ones are cis-cis in addition to transfer. That's the reason it's called epimerization. Okay, so what I will do, I will stop at this stage and I will continue in the next class.